Welcome to our short and concise tutorial on simulating a simple machine learning model in Lua. In this tutorial, we'll explore how to create a basic machine learning simulation using Lua, keeping the code clear and consistent for easy understanding. By the end, you'll have a grasp of how to implement a simple machine learning concept in Lua, presented in a visually appealing and concise format. These lines initialize the start and stop variables to define the range of numbers for our simulation, from 1 to 10, and print a message indicating the start of the simulation. Next, we set up nested loops. The outer loop iterates through numbers in the defined range, from start to stop, while the inner loop prints 5 dots to simulate a process happening for each iteration of the outer loop. The io.flush function is used to ensure that any pending output is immediately written to the output stream. This function is particularly useful when we want to ensure that data is written to the output immediately without waiting for buffering. In our simulation, we use io.flush after printing dots to ensure that the dots are immediately displayed on the screen, providing a more interactive and real-time experience for the viewer. io.flush function is used to forcibly write any pending data in the output buffer to the underlying output stream. In Lua, output to the console or a file is often buffered, meaning that data is stored in memory temporarily before being written to the output device. This buffering can improve performance by reducing the number of write operations, but there are situations where immediate output is desired, such as when displaying progress indicators or interactive messages. By calling io.flush, you ensure that any buffered output is immediately written to the output device, making it visible to the user or available for further processing. This function is commonly used in situations where real-time or interactive output is required, such as in command line interfaces, progress bars, or simulations. os.execute, sleep 0.1, uses the os.execute function in Lua to execute a shell command, specifically the sleep command, which pauses the execution of the script for a specified amount of time. In this case, sleep 0.1 pauses the script for 0.1 seconds, simulating a short delay or process happening in real time. This can be useful for creating animations, simulating real-time processes, or adding delays between actions in a script. It is important to sanitize any input passed to the os.execute function to prevent security vulnerabilities, such as command injection attacks. In this case, since we are using a hard-coded string, there is no user input involved, so the risk is minimal. However, it is still a good practice to sanitize or validate any input if it comes from an untrusted source or could be modified by external factors in a production environment. Local log value assigned to math log I. This line calculates the natural logarithm of the variable I using the math log function in Lua. The result is stored in the variable log value. Local prediction assigned to log value greater than 2 and yes or no. This line assigns a value to the variable prediction based on whether the log value is greater than 2. If log value is greater than 2, it assigns the string yes to prediction. Otherwise, it assigns the string no. This is a concise way of writing a conditional expression in Lua, known as a ternary operator. Local result string assigned to string format. The line uses the string format function and substitutes placeholders in the format string with corresponding values provided as arguments. The placeholders specify the format for each value. %d for an integer. At that case I. %.2f for a floating point number with 2 decimal places. At that case log value variable. And %s for a string. At that case the prediction variable. Note: in a real scenario, the line using the string format function should be written on a single line. However, for the sake of visibility and clarity in this tutorial, we have split the line into 2 separate lines. This allows us to explain each part of the format string and its corresponding values more clearly. When writing code in practice, it's common to keep such lines concise and readable by fitting them on a single line whenever it is possible. Finally, the print function is used to display the output of the script. In conclusion, we have successfully simulated a simple machine learning model in Lua. Throughout the tutorial, we learned how to initialize variables to define the range of data points for our simulation, use nested loops to simulate processes and generate data points, calculate the natural logarithm of each data point using the mathlog function, make predictions based on a simple decision rule, format and print the results using the string format function. By following these steps, we've gained a basic understanding of how to implement a simple machine learning concept, presented in a clear and concise format.